Hi friends, welcome to Jitesh classes. This is current electricity part 3. In last session current electricity part 2, we'll recall that now. Today I'll explain about relation between, we have left one thing, no, that one I'll explain. And next Ohm's law. In Ohm's law, at last graphs will be there, no. Those graphs we'll discuss in next session with the slopes and all. We'll discuss in the next session. Now, up to conductivity means that conductance, up to that we'll talk about that. And quickly share the video to how much as possible. And now I will not see the live chat. At last, within 2 to 5 minutes, you can ask the doubts which you have. Okay, now relation between current density and drift velocity. Okay, sorry, I'll recall that one, last one, what we discussed about that. We discussed about current density, and we also discussed about drift velocity. What is current density? Current density means the charge per unit area, means charge per unit particular cross sectional area, that is denoted by J, and that J is equals to I by A, and at instantaneous also we can say dI by dA is the J, current density. And next what we have derived is means drift velocity. What is drift velocity? When an metal conductor is connected to a power source or a battery, what happens is that in that the electrons, before when the absence of this battery or power source, electric field is not applied, then what happens, the electrons will do random motion, and due to that random motion they'll get the velocity at that thermal velocity. They'll get the thermal velocity 10 power 5 nearly 10 power 5 meters per second, and up to some extent they'll do continuous collisions with the positive ions, those lattice points. Then what happens, the energy will be decreased. The energy will be decreased, due to that they'll get energy from when the electric field is applied. The electric field applies some energy force on the charge. The energy on the charge, that energy will lead to the force, and that force leads to electric current, and as well as the velocity, and that is equals to drift velocity, Vd. And one thing, we can also say that A is negative, E by M. By deriving we will get that Vd is equals to positive, we will get. And we can say also negative also, because it is in the direction opposite to the electric current. Okay, now the relation between current density and drift velocity. Drift velocity, this is a conductor. This is a conductor, and this is the length L, and that is the average velocity, no, drift velocity as the average velocity of the electrons. The random motion is okay. This is the length, and the electrons movement will be from the positive. See, okay, we will take this positive and negative, means there are two terminals, positive and negative. It's a closed circuit, switch is on. And next, see, all conventional current will be in this direction now, from positive to negative, and electrons will move in this direction. So the movement of electron, I will be in this direction, electric field E or I, electric field will be in this direction, and the electrons will be in this direction. The velocity will be also in this direction, Vd. Okay, Vd. This is of length L. This is of length L. That length L is there, no, that's the distance. That length L is the distance. So the distance is equals to velocity into time taken, and we'll take that time is equals to delta t. Okay, what is the length now? Length is equals to velocity into time, and L is equals to Vd into delta t. Okay, and what is the volume? That's volume is equals to area into height. No, the cross sectional area of this side of this conductor is A, and that is equals to V is equals to A V D into delta T. Okay, this up to here, and we know I is equals to delta Q by delta T. We'll talk about it. In that, delta Q is equals to what? Delta Q is equals to volume into NE. See, NE, no, normally Q is charge is equals to NE. NE. So here we need NE for this charge, for this total charge, for this total conductor. So the total conductor volume, the total conductor volume into this NE is equals to the charge for this conductor, metal conductor. So NE into AVD delta T. I don't know. NE into velocity, volume. Now this I is equals to delta Q by delta T. By substituting delta Q here, NE into AVD into delta T by delta T, and this delta T get cancelled. So I is equals to NEAVD. Also, the main one we'll get now, the J. How we'll get this J? J is equals to I by A, and also, so I by A, no, this A will get here. This A, if we'll transfer from here to here, then I by A is equals to J, and J is equals to NEVD, or we can say, or else J is equals to I by A, no. So J is equals to this NEAVD by A. Okay, and now this J is equals to NEVD is the relation, is the important, these two are the important results we get here, this one and this one. J is equals to NEVD and I is equals to NEAVD. Okay, now we will discuss about Ohm's law. What is Ohm's law? See, this is very important now. This result, this means this one, this relation is very important. Now we'll talk about it. See, Ohm's law. What is Ohm's law? We'll derive V is equals to IR is the result. We'll derive IR. Okay. We'll say, and now sorry, I forgot to say one thing. N depends upon the metal number of free electrons. If there is iron, Fe plus 3, and Cu plus 2, means the number of free electrons are different. Number of free electrons are varying. So N depends on the metal. Okay. Now Ohm's law. What is Ohm's law? Ohm's law states that voltage means the electrical potential difference between 2 points in a conductor A and B. If we take and 2 points in a conductor A and B. Okay, this is A and B. We'll take these 2 points connected to a battery or a power source. Okay, A and B, the difference, electrical potential difference between 2 points is called the voltage. We'll talk about the difference in potential, electric potential, those all in the chapter electrostatics. It will be in next chapters it will be, and we should keep in mind that voltage is equals to means the potential difference is the potential difference, electrical potential difference denoted by V. Denoted by V. Here what it states that Ohm's law states that the voltage, the potential, let's see, the electrical potential energy voltage is directly proportional to the current passing through the conductor. Okay, understood? This voltage is directly proportional to the current passing through the conductor. Okay, it means that if this increases, this increases. If this decreases, this decreases. Proportional. Proportionality is this. Okay. Now we got two things. Okay, this I will be in this direction. E will be this conventional current and electrons. Okay, we got two things, that N E J is equals to N E V D, and this V D is equals to E by M into tau. Tau is the relaxation time. Okay. By substituting, means we are deriving that, means Ohm's law, no, theoretically it won't be more. By the numerically we should understand what is that states, what that states. Okay, this by this is equation 2 and this is 1. By substituting this in this equation 2 in equation 1, J is equals to NE into E tau by M. E tau by M, and this is equals to J is equals to N E square by M into tau into E. I written E outside, the electric field outside, because this is electric field in the direction of positive terminal to negative terminal, electric field. Okay, electric field. See, and one thing in Ohm's law is that it is the condition of this Ohm law is at a fixed physical property, it depends on the temperature and the material. The material means aluminium or something. The material which we took as the conductor is called is depending upon that. Means material and the temperature. Those all are depending upon that. And some keywords I'll say that conductor. Conductor means what? It allows the current to pass through it, and resistor means that will oppose the current to pass through it, to pass through the conductor. When it is passing, that will oppose, that is resistor. Keep in mind, those will be conduct means allowing the current, and resist means in this current electricity, resist means opposing the current. That some keywords, those are important. Okay, now coming to our derivation, J is equals to NE square, this is tau by M. Okay, tau by M into E. Why I took this? Because N is a constant, means for the material which we have to, the N will be constant, means N will be +3 means +3, like that it will be constant. And E square, what is E square? Charge, means NE, the charge also will be, means the charge also will be equal, means the E is equals to 1.6, those coulombs, that one there, no, that will be also that's a constant value. And this tau is that's also depends upon the material, means the relaxation time between some successive collisions, that is tau. That tau is also a constant, and this M, mass, is also a constant for the electrons. So these are all constants, and this electric field, how much we apply, that much will flow. So that electric field will vary, that's not a particular constant. Okay, so this is called the sigma. We'll say that sigma. That sigma is the conductivity. Sigma J is equals to sigma into E. Important one. This is an important one. Simple and important one. J is equals to sigma into E. And that sigma, I'll have this part, this complete part. Sigma J is equals to sigma into E. Sigma into E. And that sigma is conductivity. That sigma is conductivity. Conductivity. And conductivity means allowing the current. Okay, conductivity means, see, conductivity means the ability of conductance. What is conductance? How much means how much ability. See, this conductivity means ability of the ability of conductance. And the conductance means what? The conductor means, in that conductance means it will how much it is allowing. And this is how ability of conductance. Okay, some difference will be in these two. And that conductance, see, conductivity means allowing the current. Resistivity means opposing the current. That opposing the current is inversely proportional. It means opposing the current is inverse to conductivity. So it is the 1 by sigma is resistivity. Okay, resistivity. And that resistivity is equals to the rho. We will call rho or something. This is the symbol of that. 1 by, okay, 1 by sigma is 1 by conductivity is equals to resistivity. Now we will derive the formula V is equals to IR. Okay, keep in mind this all. I'll write here. Sigma is equals to 1 by rho, or 1 by rho is equals to sigma. Okay. Now J is equals to sigma into E. What is sigma? Okay, sorry. Here E is equals to E is equals to V by L, voltage per length. If this is of length L, this conductor is of length L, and this sigma, this V, voltage, is the potential difference. If this, we will take these 2 points at these 2 ends, that is the potential difference. Then what? Electric field is equals to the voltage per this. See, if this is a conductor, in that these 2 are the ends, these 2 are the points of the conductor to allow the current. Okay, these 2 are the end points, and this length is L. Okay, that V by L, voltage per this length of the conductor, is equals to the electric field E. So, and also we know the J is equals to I by A. And this I by A is equals to sigma into V by L. And that V is equals to, see, this V, sorry, I am writing for everything, this borders, and this C, V is equals to this L this side, we will send this L this side and sigma this side. So I into L by A into sigma, or we'll write this as outside 1 by sigma. And that 1 by sigma, okay, clear up to here, means L by A into 1 by sigma. L by A into 1 by sigma. And this V is equals to I into this L by A into this rho, conductivity. Okay, into rho. And this, okay, wait. And that rho L by A is resistance. V is equals to I into that rho L by A. 1 by sigma is rho, 1 by sigma, okay, 1 by sigma is rho, we know already. 1 by sigma is rho, so this is the conductivity, sorry, the resistance. The resistance, so V is equals to I into R. IR, we derived the formula IR, okay. V is equals to IR, and one important thing, rho and this sigma and the rho are depending upon material and temperature. Already I said about it, why they are depending upon it. Okay, now this V is equals to, see, V is equals to IR, no, then this R, resistance R, this is resistance, R is resistance and rho is resistivity. Okay, I'll say about resistance now, I'll say now. And this R is there, no, this V by I, see, those are proportional. R is proportional to V and R is inversely proportional to I. But R does not depends on V and I, because resistance is constant. Means if it is there, this is the graph, see, why the graph of this resistance will be straight, because I'll say the graphs in the about the slope and the tan theta will be said in the next session. But why it will be straight, just that one I'll say now. See, because this is the graph and we'll take this as V and I. See, this one there, no, this is there. If we'll take 10, this is 0, okay, origin, and this as 10 and this as 10, then it will go as 10. And if we take voltage as 20, this should be also 20, so that will be constant. If it is 1 by 2, then it should be 10 and it should be 20. If it is taken 10 and if it is taken 20, that will be double of it, because 1 by 2 means it will go 1 by 2, it will go upon a straight line. It will not go at the same thing. So it will go at a straight line at that fixed physical property, means fixed temperature, and that means some conditions, physical conditions are there. And when those are not taken at that particular condition, if they are changing, then what happens, the graph will come like this. The graph will be in this one, or if we take negative one, this way, because and these will be said in the semiconductors, holes and those electrons, holes, those will be a topic in that. These I'll say that will be straight line, because means resistivity will be constant, means it will be, if we take that quantity, the voltage and I should be same. That is a condition, okay. Means that at a particular given condition, fixed physical condition, okay. And now about resistance. My notes will be available in the PDF. I'll write, because before 20 days this chapter is completed to me, and I am preparing the notes. That will be, my handwritten notes will be updated shortly in 10 days. In that every video of this chapter, I'll update that. I'll give the link in the description of every video of the current electricity, okay. Handwritten notes of me. And now resistivity is equals to R, and R is equals to, and sorry, Ohm's law, that is equals to volt per meter. Okay, that unit volt per ampere, sorry, volt per ampere is equals to omega. We can say you learn this in 10th class, that parallel resistors will be, and those parallel resistors line, and those will be some, you will learn those in 10th class already. You may learn. Okay, and volt per ampere is omega, and here rho L, 1 volt per 1 ampere is omega. Okay, that's for Ohm's law, that we have already derived. V is equals to I R, that one. Okay, R is equals to rho L by A. We got this formula before. We already got this formula, derived this formula, that is the constant. Or we can say in another method that V is proportional to I. The statement is V is proportional to I. If we will make it should be equal, then we'll take a constant R. Means that in mathematics you will learn, if V is equals to I, V is proportional to I, then V is equals to IR. In basic mathematics of physics, I'll say that one also by starting in some 1A. I'll start that. Okay, V is equals to IR, means we will take that constant, and that constant is R, and that R is equals to resistance. Okay, we can represent in the statement form as this. Okay, R is equals to rho L by A. Okay, rho L by A, and this SI unit is this ohm omega per meter. Omega meter, sorry, no, omega per meter, that's not omega per meter, omega meter, ohm, and this is resistance. Okay, resistivity only, resistance is R, and resistivity means rho, and resistance is R. So this rho is equals to AR by L, or RA by L. For resistivity, this is the SI unit. Okay, and conductivity that is not, it is not correctly, it is represented by sigma we know, that is 1 by omega, and sigma is equals to 1 by rho, and that rho we got RA by L, and here L by RA, because 1 by means 1 by RA by L, and that is equals to L upside and R by L by RA. Okay, for that MHO means omega per meter, omega inverse meter inverse, not per meter, omega inverse meter inverse. So mho, we can say that it is normally called as mho. We can normally call means we can keep in mind that, like that, we can remember it like that. Okay, that, and this conductivity is equals to conductance, resistance and conductance. It is not represented by anything, means no denotion, any symbol. So it is equals to 1 by R, and that 1 by R is equals to, we know that as A, that one the same only, 1 by R, R we know is equals to 1 by R is equals to rho L by A, and it is equals to A by rho L. This is conductance, and this is Ohm's law, and we will say non-Ohm's law limitations, and those also in the next chapter, and the graphs also, limitation graphs, and these graphs I will say in the next one. And now doubts, if anyone have asked doubts. Wait one second. Wait guys, once it is loading. Here are some. Hi Ramarvin, hi. Uh, do you have, if you have doubts you can ask in the doubts, if you can ask in the live chat. Don't you have any doubts? Hi Devika, hi Sujata, hi Pavani, hi Nagarjuna, hi Shanmukrao. Any doubts? Don't I think no one have doubts. Okay, thank you for watching this video. If you like my explanation, kindly like, share and subscribe to my channel. Bye.